So, pretty typical free response question. This graph was used on the 2000 AP exam. It was question number 3. I've modified it slightly so that we could have some good conversation. So the figure below shows the graph of f prime. If that's not really clear to you, I would write it myself. This is the graph of f prime. This is the graph of the derivative of a function. We don't know what the original function is. All we have is the graph of f prime. And because this is what we know, this is the graph, all of our justifications are going to have to go back to how is the f prime behaving, and that's how we'll answer our questions. So this is the derivative of a function for the domain -7 less than or equal to x less than or equal to 7. The graph of f prime has a horizontal tangent line over here at x equals -3, a horizontal tangent line over here at x equals 2, and a horizontal tangent line over here at 5, and a vertical tangent. I know we've talked about these in class. It's really hard to ever see a vertical tangent, but that is a vertical tangent line over there at x equals 3. Based on this information, we're going to answer a series of follow-up questions that I've spread out over the next few slides. Okay. So question A, find all values of x for which f attains a relative minimum. So this is what I would want to see. F has a relative minimum, and we can just abbreviate that REL MIN. Well, what does that tell me? That means that f prime must be changing. If f has a relative minimum point, then before that minimum point the derivative is negative. After that minimum point the derivative is positive. F prime changes from negative to positive. Where on this graph do we see f prime changing from negative to positive? Or another way to say that is, where does f prime change from being below the x-axis to above the x-axis? And that happens right here at x equals -1. So x equals -1 is the relative minimum point, or it's the x-coordinate for the relative minimum of the original function. Done. This is normally, a question like this would be worth 2 points. The first point comes from your properly identifying where the relative minimum occurs. The second point comes from your being able to defend why you selected this point. We selected x equals -1 as the relative minimum because f prime changed from being negative to positive. If you do that, if you get in this habit of justifications, you are going to get all the points and you're going to be a happy individual in May. I guess July is when the test results come in. B, find all values of x on that open interval -7 to 7 at which f attains a relative maximum. Well, we can do this one quickly. If f has a relative max, then f prime changes from positive to negative. Where do we see that change from being above the x-axis to below the x-axis? That would tell me at x equals -5. This is going to be the location of your relative max. This will be the location of your relative min. And if there were actually students in the room with me, I'm sure somebody would ask me about this point. What's happening at x equals 5? F prime changes from being positive to being positive. So the function goes from increasing to flattening out to increasing. It does something like that. Right? Increase, flatten out, increase. That's not a relative max, nor is it a relative min. Fancy word there, that's a saddle point. Don't worry about saddle point, at least not right now. All right, C, determine the x-coordinates for all horizontal tangent lines to the graph of f. Well, if f has a horizontal tangent, then that must mean that f prime, f has a horizontal tangent, tells me, it implies that f prime is equal to 0. Where is f prime equal to 0? Over here at x equals -5. over here at x equals -1, and over here at x equals +5. All right, part D. Find all values of x on that interval at which f is concave down. If f is concave down, well, I can make two claims. If f is concave down, then f prime is decreasing. And I can also claim that f double prime, the derivative of the derivative, is negative. The only one that I can really use is the one that relates back to f prime. I need to know where f prime is decreasing. And I see f prime is decreasing starting at -7, going towards -3. So from -7 to -3. And right now I'm going to use brackets, but I have to fix that because that is incorrect. It is f prime is decreasing from -7 to -3. F prime is also decreasing from 2 to +5. So you might do 2 to +5. For questions about where something is increasing or decreasing, brackets is the way that we go. However, when it comes to concavity, we can never include the endpoints. So we are going to just use parentheses. I'm not going to belabor the point right now, but keep in mind when we talk about where our function's increasing or decreasing, we're always going to use brackets as long as the function is defined at each point. When it comes to concavity, we're going to use parentheses. All right, we're almost done. E, determine all points of inflection of capital F. Well, if capital F has a point of inflection, then that means that if I take two derivatives on the antiderivative, f double prime changes from positive to negative or negative to positive. But what is f double prime? Well, let's think about that chain. You have f, the antiderivative. You have little f, the original function, f prime, and f double prime. Which of these is f, big F double prime? This one. So what we can say is we need f prime to change from positive to negative, or f prime changes from negative to positive. Where does f prime change from being positive to negative? We've already answered this question once before. F prime changes from being positive to negative at x equals -5. So right here. F prime changes from being negative to positive at x equals -1. So I would conclude and say, so f has a point of inflection at x equals -5 and x equals -1. That would be my conclusion. This would be all my supporting evidence for that. Okay, part F. I want a point of inflection for little f, not capital F. F has a point of inflection. If you look at the table, if f has a point of inflection, f prime has a relative max, or it has a relative min. F prime has a relative max where? I can look at the graph and I can see f prime has a relative maximum at x equals 2, and f prime has a relative min at x equals -3. F prime also has a relative min at x equals 5. So all of those are true, which means I can conclude that f has a point of inflection at x equals 2, at x equals -3. Sorry, that's just bad handwriting on my part, -3. And x equals 5. Little f has 3 points of inflection. Let's move on to the last two. In part G, we're given that f of -3 is equal to 4. and we want the equation of the tangent line. Well, f of negative 3 equals 4 is telling me that the point negative 3, 4 is on the graph of f. Okay, I have a point. This is my point. It's a point on the tangent line. What I need is the slope of the tangent line at x equals negative 3. Another way to say that is I need f prime of negative 3. Well, what is f prime of negative 3? F prime of negative 3 is negative 2. I get that from looking at this point and recognizing that the y value here is what f prime is at negative 3. So this is my slope. I would use that to conclude that the equation of my tangent line is going to be y equals m. This is my m, negative 2, x minus my x point, so x plus 3, plus 4. What did I do? That was just your point slope form. Y equals m, x minus x1 plus y1. That's the equation of your tangent line. In part H, using a tangent line approximation, estimate the value of f of negative 2.8. Well, what we've talked about before is that the tangent line for any function, whatever the function might look like, let's say the function does this, okay? If I find the tangent line, that's what the green is going to represent, that's my tangent line. The tangent line is very, well, at this point of tangency where they touch, the tangent line and the original curve are exactly equal to each other. If I go slightly to the right and I find the point on the graph of f, and I find the corresponding point on the graph of the tangent line, they're not that different. What that means is we can use the tangent line to approximate the value of the function. And that's what we're being asked to do here. We want to approximate f of negative 2.8. So I would say f of negative 2.8, double wiggle, right, approximately, negative 2, and replace the x with negative 2.8. So we get negative 2. Negative 2.8 plus 3 is 0.2 plus 4. We get negative 0.4 plus 4, which is 3.8. So I can conclude that f of negative 2.8 is approximately 3.6. Done. Nice job if you've made it through this part of the video. I hope you find this helpful, and I'll be posting this later on tonight.